Hi. In this video, we're going to take a look at the acceleration. But first, a brief revision of the terminology we learned previously. So we need to state that we have quantity called distance, also displacement, which talks about how far objects are away from one another. We also have time, which talks about duration of events or the interval between the event. And finally, we have speed, which is the distance traveled per unit time. And those have their vector correspondences. So this would have a correspondence of displacement, and speed will have a correspondence of velocity. And now we're ready to introduce the quantity called acceleration. So we're going to define acceleration as the rate of change of velocity. And we can calculate acceleration using the following formula, where acceleration A is equal to the final velocity v, taking away the initial velocity u, and all that divided by time. And just a reminder that initial and final velocities are always represented with the same letters u and v respectively. Acceleration is a vector quantity with an SI unit of meter per second squared, written meters second to the power of -2. And we're going to again add that acceleration is calculated by dividing the change in velocity by the time taken. So let's take a look at how it's done on an example. Please pause the video and try to solve it on your own using the formula just learned, and then let's take a look at the solution together. Okay, so I have a car, and the car accelerates from initial velocity u equal to 5 to the final velocity v equal to 40 in time equal to 5 seconds. And I know that the formula for acceleration is final take away initial and divided by time. And if I substitute the values into my problem, I'm going to end up with 40 take away 5 divided by 5, which is the same as 35 over 5, which is 7 meters per second squared. And that's the acceleration of this particular object. Now, with the acceleration comes the first set of equations that we need to be able to derive. And these are Newton's equations of motion. So just before we introduce these equations, let's look at the quantities. So I have initial velocity u, final velocity v, acceleration a, displacement s, and time t. And we can combine those quantities with the following three formulas. So the first equation talks that final velocity v equals to initial velocity plus acceleration multiplied by time. The second equation allows us to find the distance, and the distance equals to initial velocity multiplied by time plus half acceleration times squared. And last but not least, connects the final velocity with initial velocity and distance by saying v squared equals to u squared plus twice acceleration times the displacement. And we need to be able to derive those equations. So let's do it. Our starting point for v equals 2 plus at is to say that acceleration equals to v minus u, all that divided by time. I'm going to multiply everything by time to end up with at equals to v take away u. And moving things to the respective sides, I get that v equals to u plus at, which is exactly what we are asked for. To derive the second formula, I need to use the statement about the relationship between the average velocity, v average, equals to initial velocity plus the final velocity, all that divided by 2. And I need to add that into my formula for distance, s equals to average velocity multiplied by the time. So by substitution, I'm going to end with the following expression. And then I remember that final velocity equals to initial velocity plus acceleration by time. So now I can substitute to get u plus at, all that divided by 2 multiplied by time. And simplifying, I end up with u plus 1/2 at squared, which is, sorry, ut here, which is exactly the same as the relationship we were trying to derive. And last but not least, we have our derivation of the relationship between final and initial with distance. So our starting point is to say that v equals to u plus at. I'm going to square both sides and end up with v squared equals to u squared plus 2uat plus 2at squared. And then I'm going to look at the final two terms and take 2a out as my common factor. And this is the expression I'm ending up with. U squared plus 2a. From the first one, if I take 2a, I'm ending up with ut. From the second, just there's a mistake here. Let's get rid of this. Plus a squared t squared. So if I take that out, I'm ending up with a t over 2, all that squared. And hopefully you can see that the bracket can be replaced with s. So I end up with an expression u squared plus 2as, which is exactly what we were looking for. Okay, so these are the three derivations. And before we move on, just want to highlight that those three equations are all going to be used in solving of the physics problems, so we need to be quite familiar with those. So thank you very much for your time and your attention.
If you like this video, you'll love our notes. You can get some for free in the link in the description of this video.